Download this code from codegive.com, link in the description below. OK, let's dive deep into troubleshooting Dataproc cluster creation errors. Dataproc, Google Cloud's managed Hadoop and Spark service, streamlines big data processing. However, its complexity means cluster creation can sometimes fail. This tutorial provides a comprehensive guide, covering common errors, debugging techniques, and code examples to help you create your Dataproc clusters successfully. Understanding the Dataproc cluster creation process. Before we troubleshoot, let's outline the Dataproc cluster creation flow. 1. Request submission *. You submit a cluster creation request to the Dataproc API. This request includes configuration parameters like cluster name, region, zone, machine types, image version, initialization actions, metadata, and component gateway settings. This can be done via the Cloud CLI, the Google Cloud Console, or the Dataproc API itself, through languages like Python, Java, etc. 2. Resource provisioning * Dataproc attempts to provision the necessary Google Cloud resources, compute engine instances, VMS, persistent disks, network configurations, firewall rules, subnets, and potentially cloud storage buckets. 3. Software installation and configuration * Dataproc installs and configures the specified Hadoop and Spark components on the VMS. This includes setting up core Hadoop daemons, HDFS name node, resource manager, Spark master, and worker processes, and other components you might have requested, example Hive, Pig, Jupyter. Initialization actions, scripts, run during this phase to perform custom setup tasks. 4. Cluster initialization * Dataproc performs final configuration steps, verifies component functionality, and marks the cluster as active. 5. Error handling * If any step fails, Dataproc attempts to diagnose the cause and reports an error message. It might attempt to roll back changes. The creation attempt will eventually be marked as failed. 2. Common Dataproc cluster creation errors and solutions. Here's a breakdown of common errors, their potential causes, and how to resolve them. 1. Insufficient permissions / IAM roles *. Error permission _denied, does not have storage. Buckets. Get access to bucket. Permission _denied, missing necessary permission to create instance. Permission _denied, user does not have permission to perform this action. Cause * the account used to create the cluster, your user account, or a service account, lacks the necessary IAM roles to access Google Cloud resources, compute engine, cloud storage, cloud networking, etc. Solution *. Identify the account * determine which account is being used. If using the Cloud CLI, it's likely your user account. If creating clusters programmatically, it's typically a service account. Grant required roles * grant the account the following essential roles. You can use the Google Cloud Console or the Cloud CLI. Role / Dataproc.worker, allows Dataproc workers, VMS, to interact with other Google Cloud services. Essential for cluster functionality. Role / storage.object admin, provides read / write access to cloud storage buckets used by Dataproc. Crucial for storing logs, input data, and output data. Role / compute.instance admin.v1, allows creating and managing compute engine instances. Necessary for provisioning the cluster's VMS. Role / compute.network admin, enables creating and managing networks and firewall rules. Needed if you're specifying a custom network. *roles/logging.log writer allows Dataproc to write logs to cloud logging. *roles/serverkey usage.service usage admin allows the cluster to enable and disable Google Cloud APIs. *roles/im.service account actor, this role is required if you're using a service account for the cluster's VMS, specified via -service account flag. The user account performing the cluster creation needs to be able to impersonate the service account. Example, Cloud CLI. Service account impersonation. If using a service account, ensure the account creating the cluster, your user account or another service account, has the service account user role on the Dataproc service account. This allows the creator to impersonate the service account for cluster creation. 2. Resource quota exceeded. Error quota _ exceeds quota for, in region. Resources exhausted in zone. Cause you've exceeded your project's quota for resources like compute engine instances, CPUs, persistent disks, or network resources in the specified region/zone. Solution check quota usage. Go to the Google Cloud Console-im and admin-quotas. Filter by the service, compute engine, Dataproc, and region to see your current usage and quota limits. Request quota increase. If you need more resources, request a quota increase through the Google Cloud Console. Provide a clear justification for your request. Be patient, quota increases can take some time to be approved. Reduce resource consumption. Consider using smaller machine types, reducing the number of workers in your cluster, or using a different region with more available resources. You can also try cleaning up unused resources, example old VMS or persistent disks. 3. Network configuration issues. Error invalid _argument, invalid network URI. Invalid _argument, invalid subnet URI. Could not resolve host, metadata.google.internal, often within initialization actions. Cause invalid network/subnet. The specified network or subnet doesn't exist, or you don't have permission to use it. Firewall rules. Firewall rules are blocking necessary communication between VMS in the cluster or between the cluster and external services, example cloud storage. No external IP address, private clusters. If you're creating a private cluster, no external IP addresses on the VMS, you need to ensure proper DNS resolution to access Google Cloud APIs and services. Solution verify network and subnet. Double check that the network and subnet you specified exist and are in the correct region. Make sure you have permission to use them. Firewall rules. Default firewall rule. Ensure that the default firewall rule is enabled and allows traffic between instances within the same network. Ingress TCP 0-65535 UDP 0-65535 ICMP. This is crucial for hadoop and Spark to communicate. Custom firewall rules. If you're using custom firewall rules, ensure they allow the necessary traffic. Specifically, ensure that traffic is allowed on the hadoop and Spark ports, example 8088, 7077, 50070, 9870. Also, be sure to allow outbound traffic to storage.googleapis.com if you need to access cloud storage. Private Google access. For private clusters, enable private Google access on the subnet. This allows VMS without external IP addresses to reach Google Cloud services using private IP addresses. Cloud DNS for private clusters. Configure Cloud DNS with a private zone for star.googleapis.com that points to the private Google Access IP address 199.36.153.4/30. This ensures that the VMS can resolve Google Cloud Service endpoints. *SSH access * If you need to SSH into the cluster nodes, make sure you have firewall rules that allow SSH traffic, port 22, from your network or a jump host. Example, Cloud CLI, creating a cluster with a specific network and subnet. Example, Cloud CLI, enabling private Google access on a subnet. For initialization action failures ***. Error initialization action failed. Failed action, with non-zero exit code. Cause an initialization action script, specified via the -initialization actions flag, failed to execute correctly on the cluster nodes. This could be due to script errors. The script itself contains errors, syntax, logic. Missing dependencies. The script relies on software or libraries that are not installed on the cluster nodes. Permissions issues. The script doesn't have the necessary permissions to perform certain actions. Network issues. The script needs to download files from the internet, and the cluster nodes cannot reach the internet, example in a private cluster without proper configuration. Solution. Review logs. Examine the logs for the failed initialization action. These logs are stored in cloud storage in a bucket associated with your Dataproc cluster. The error message in the Dataproc console usually provides the GCS path to the logs. The logs will contain the standard output and standard error from the script execution, which should help you identify the cause of the failure. Log files are usually under gs/cluster staging bucket /Google Cloud Dataproc /initialization action /action name /hostname.log. Test locally. Try running the initialization action script on a local VM or a similar environment to the cluster nodes. This can help you identify errors in the script more easily. Add error handling. Include error handling in your initialization action scripts, example set E to exit immediately on errors, and proper error logging. Dependency installation. If the script relies on specific dependencies, make sure to install them within the script using package managers like apt-get, yum, or pip. Permissions. Check the permissions of the script and the files/directories it interacts with. Make sure the script has the necessary permissions. Network connectivity. If the script needs to access the internet, ensure that the cluster nodes have proper network connectivity. For private clusters, configure private Google Access and Cloud DNS as described above. Example, initialization action script with error handling. 5. Image version compatibility. Error invalid _argument, specified image version, is not supported. Cause you're trying to create a cluster with an older or unsupported Dataproc image version. Solution. Use a supported image version. Check the Dataproc documentation for the list of supported image versions. Use the -image version flag when creating the cluster. It's generally recommended to use the latest stable image version. Check available versions. You can list available image versions using the Cloud CLI. 6. Metadata configuration problems. Error. Errors arising from custom metadata you've defined, often related to startup scripts or configuration. Cause metadata keys or values are invalid, missing, or conflicting, causing issues during the VM startup process. This can result in scripts failing to execute or incorrect configurations. Solution review metadata keys and values verify that your metadata keys and values are correctly formatted and that they adhere to any expected format, example JSON, YAML. Check for conflicts. Ensure that your metadata doesn't conflict with default Dataproc metadata or any other configurations. Conflicting metadata can lead to unpredictable behavior. Test metadata scripts. If your metadata includes startup scripts, test those scripts independently to ensure they function as expected. Debug any errors in the scripts before deploying them in the cluster configuration. Logging. Add logging to your startup scripts to track their execution and identify any errors or unexpected behavior. Log files can provide valuable insights into metadata-related issues. 7 Component gateway errors. Error. Problems accessing the component gateway, example Jupyter, Yarn UI, after the cluster is created. Cause. Firewall rules. Firewall rules are blocking access to the component gateway ports, example 8088 for Yarn, 8888 for Jupyter. Service account permissions. The service account associated with the cluster doesn't have the necessary permissions to run the component gateways. External IP addresses. The component gateways require external IP addresses on the master node to be accessible from outside the Google Cloud network. Proxy/browser issues. Proxy settings or browser configuration can interfere with access to the component gateways. Solution. Firewall rules. Ensure that firewall rules allow traffic to the component gateway ports, example 8088, 8888, from your network. If you're accessing the gateways from outside Google Cloud, you'll need to allow inbound traffic from your IP address. Service account permissions. Verify that the service account used by the cluster has the necessary permissions to run the component gateways. The role/dataproc.worker role is often sufficient. External IP addresses. Make sure the master node has an external IP address. If you're using a private cluster, you'll need to configure a bastion host or VPN to access the component gateways. Browser/proxy settings. Check your browser and proxy settings to ensure they're not interfering with access to the gateways. Try using a different browser or disabling your proxy. Example, Cloud CLI, creating a cluster with component gateways enabled. 3. Debugging techniques. Check the Dataproc console. The Google Cloud Console provides error messages and status updates for cluster creation attempts. Pay close attention to these messages, as they often contain clues about the cause of the failure. View logs. Dataproc driver logs. Dataproc driver logs contain information about the cluster creation process. These logs are stored in cloud logging. You can filter logs by resource type, Dataproc_cluster, and severity to find relevant error messages. Initialization action logs. As mentioned earlier, initialization action logs are stored in cloud storage and contain the output of the initialization scripts. VM serial console output. You can access the serial console output of the Compute Engine VMS in your cluster. This can be helpful for debugging issues related to VM startup or boot failures. You can access the serial console through the Google Cloud Console. Simplify the cluster creation. Start with a minimal cluster configuration to isolate the issue. For example, try creating a cluster with only one worker node and no initialization actions. Once you've successfully created the basic cluster, gradually add more features and complexity to identify the source of the error. Use Cloud Dataproc diagnose. This command can help identify common configuration issues that might prevent Dataproc cluster creation. It performs checks for IAM permissions, network connectivity, and other potential problems. Review Dataproc documentation. The official Dataproc documentation is a valuable resource for troubleshooting and finding solutions to common problems. 4. Code examples, cluster creation using the Dataproc API. Here are examples of creating Dataproc clusters programmatically using the Dataproc API in Python. Key considerations when using the API. Authentication. The API clients require proper authentication. These examples use Google Application Default Credentials, ADC. Ensure you've configured ADC correctly, example by setting the Google_application_credentials environment variable or running Cloud Auth application default login. Error handling. The code includes basic error handling, but you should implement more robust error logging and reporting in production. Consider catching specific exceptions to handle different error scenarios. Asynchronous operations. The create_cluster method creates the cluster asynchronously, using the operation object. This allows you to track the progress of the cluster creation and handle potential failures. The operation.result call waits for the operation to complete, but you can also use operation.done to check if the operation is finished without blocking. Best practices for Dataproc cluster creation. Use infrastructure as code. IAC tools like Terraform or Deployment Manager can help you define and manage your Dataproc clusters in a declarative way. This makes it easier to reproduce your environments and reduces the risk of configuration errors. Validate configuration. Before creating a cluster, validate your configuration to catch potential errors early on. Use the Cloud Dataproc clusters diagnose command to identify common issues. Monitor cluster creation. Monitor the progress of cluster creation using the Dataproc console or the API. This allows you to identify and address any problems quickly. Implement robust error handling. Implement robust error handling in your cluster creation scripts and initialization actions. Log errors to cloud logging to help you diagnose problems. Keep software updated. Use the latest stable Dataproc image version and keep your initialization actions up to date with the latest software versions and security patches. By understanding the Dataproc cluster creation process, identifying common errors, applying debugging techniques, and following best practices, you can significantly improve your success rate when creating Dataproc clusters and build reliable big data processing pipelines. Remember to carefully review error messages, logs, and documentation to diagnose and resolve issues effectively. Good luck.